So in this section, we're going to factor the following polynomials completely. And the first one here is a little bit different than the other ones that we factored. This is the factor of 2 squares. So looking at this, I know that I can get this first term by squaring something, and I can get the second term by squaring something. And because it has a negative in between the two things, it works for our pattern. I will have 2 different sets of parentheses. One of them will be negative and one will be positive, but they will have the same terms on the left and the right. And it'll always follow the same pattern. If you have 2 terms that are something squared with a negative in between, it'll always look like this after it's been factored. So first I'm going to take that first term, and I know that if I take the square root of 81x squared, I get 9x. Because if I square 9x, I get 81x squared. So 9x is my first term, and it's going to go on the left on both sides. Now I have to figure out what I need to square to get to 4y squared, which would be 2y, because if I square 2y, I get 4y squared. So 2y is what I'm going to put on the right side of both of these. And let me just FOIL that out to show you how this works. So when I multiply that, I'm getting my 81x squared. When I do the outer terms, I get a positive 18xy. When I do the inner terms, I get a negative 18xy. So it's going to make these two things cancel out completely. And then when I multiply those last 2 terms, I get that negative 4y squared. And that's why it has to be a negative sign in between, because it's going to cause this thing where you get a plus and a minus of the same thing and get something to cancel out. And that's really important. So that is my final answer there. Now let's look at number 9. This one is also sort of a factor of 2 squares, but there's something I have to do first. I'm going to look at both sides of this equation and see if there's anything I can factor out of all of the terms, if they have anything in common. So 16 and 49 don't have any common factors. There is an x squared on this side, but there's no x squared over here. There's a y squared on this side, but there's no y squared on the right side. But they both have an a squared. So before I even start, I'm going to factor out that a squared. I'm going to divide the whole thing by a squared and take it out of everything. So I'll put that a squared on the left here. And after I divide that out, I'm left with 16x squared y squared minus 49z squared. And now this is a little bit easier for us to look at. So I need to figure out what the square root of this is and what the square root of this is. And it has that negative sign in between, so it will follow the same pattern as the last one. So I'm going to end up with a squared times 2 different sets of parentheses. And one will be a negative and one will be a positive. So if I take the square root of 16x squared y squared, I'm left with 4xy. So I'm going to put that on the left side of both of these parentheses. And if I take the square root of 49z squared, I'm left with 9z, and that's going to go on the right of both sides. And if I factored through that, you would see that I end up back at the same thing as before. Okay, let's look at the next 2 problems. So number 10 is just kind of a normal factoring problem here. But before I start, I'm going to go through and see if there's any common factors that I can take out of all 3 terms. And looking at this, I can see that they all have an x in common. They all have at least one x, so I'm going to take an x out of all of them. Also, usually if you see a negative at the front, I would factor out a negative from the whole thing. So I'm going to factor out a negative x from this entire thing, which means I'm going to divide a negative x out of every single term. So if I divide this by a negative x, I'm left with x squared. If I divide this by negative x, it has to switch that positive to a negative, so I'll have a negative 15x. I only have one x left. And if I divide this last term by a negative x, that 2 negatives will change to a positive 50 without any more x's on the end. So that helped this look like a normal factoring problem, where we have 2 x's, 1 x, and then no x's. And that is the pattern that we should see when we're factoring. So now I can just factor this like normal. I'm going to set up my two sets of parentheses. And I don't know the signs yet. And I'm going to find the factors of 50 that add up to 15. So let me write out my factors of 50 here. I have 50 and 1, 25 and 2, 5 and 10, and that's it, I found it. So 5 plus 10 would get me to 15, but I need to get to negative 15. But if I had a negative 5 and I added that to a negative 10, that would get me negative 15. So those are the two numbers that I need. I will have a negative 5 over here and a negative 10 over here. And if I read that left to right, negative 5 minus 10 does get me to negative 15. And now I just put my x on each side. And let me factor that out to see if that worked for me. So when I FOIL this, I get x squared. My outer terms gets me to negative 10x minus 5x plus 50. And when I combine these like terms here, I end up with x squared minus 15x plus 50, which is the same thing that I started with over here. So I did it right. And that is my final answer. Now let's look at the last one, number 11. So again, the first thing that I do before I factor is I look at all the terms and I see if there's anything that they have in common that I can factor out first. So these coefficients, 2, 4, and 70, have a common factor. They can all be divided by 2. So let me divide out a 2 before I even start. So if I take a 2 out of every single term, I'm left with a squared minus 2a minus 35. And now I can factor this. It'll be a little bit easier for me. And I'm going to find those factors of 35 that add up to negative 2. So if I write out the factors of 35 here, and I need to get to a negative 35, that's important. I could have 35 and 1, 7 and 5, and that is the one that I need. So with the numbers 7 and 5, if I want to get to a negative 2, and have a negative 35 as the sum, at least one of those numbers is going to have to be negative. So let's say I start with a positive 5 and I subtract 7, that would get me to negative 2. So when I set up my parentheses here, I got to keep that 2 on the outside because I factored that out in the beginning. Both sides will have an a. One side will be a negative 7 and the other side will be a positive 5. And if I read that from left to right, I can see that negative 7 plus 5 does get me to that negative 2 that I need. Let me just FOIL that real quick, just check. First gets me a squared, outer, plus 5a, inner, negative 7a, and the last terms gets me to that negative 35. After I combine these like terms, I'm going to end up with a squared negative 2a minus 35, which is exactly what I started with up here, which means I did it right.